Hello everyone and welcome to new video. In this video, we are going to talk about object-oriented programming in Python. We will also be discussing why do we need object-oriented programming and what kind of programming we were doing until now. So we were using functional programming until now. We were dividing our code into different functions, and that was a lengthy process to write the code. That's not the efficient way to write the code. Okay. So if I have to describe object-oriented programming in one word, I'd use the word efficient. Okay. So there are many features which comes with object-oriented programming like the security, efficiency, less code, reusability, and a lot more. The list continues. Okay. So that's why we should use object-oriented programming. But before starting with the object-oriented programming, we must first know what is exactly object-oriented programming, how we are going to do the object-oriented programming. So in object-oriented programming, there are two key things. First is a class and another thing is an object. Okay, first is the class and another is the object. So first we'll take an example. We'll learn from an example, then we'll discuss about the definitions. Okay, so let's take your example. You are a human being, right? Now you might be a boy or girl, it doesn't matter, but you are a human being and you have different methods in the sense you can perform tasks like you can dance, sing, or you let's say speak, or hear, or walk, or run. These are your methods. Okay, there are a lot more, but let's count these basic methods only. Okay, you can walk, dance, run, speak. Okay, so these are your methods. Okay, and on the same time you have some attributes. On the same time you have some attributes. What are your attributes? Your name, your age, let's say which city you belong to, which nationality you belong to, or something else like your weight, etc., height. These are your attributes. So let's take your example. You are an object. You are an object. Just take this example, and you have methods. What are the methods I talked about? Like you can walk, run, speak. Okay, just count these three as of now, and you have some attributes. You have some attributes. What do I mean by attributes? Your name, let's say your age, your city, the data which is belong to you, the data which belongs to you. I specify them as attributes. Okay, so these are your features, right? You have some attributes like name, age, city, or let's say nationality, etc., which can be counted. Now, an object is divided into two parts. But how do we get an object? Then what is a class? Now, we are clear about the object, but what is a class? So you are a human, right? You are an object of class human, because you are a human, right? You belong to the class human. So what is a class? Class is a blueprint to create object. Class is a blueprint to create objects. Okay, so basically you belong to the class human, so all the humans have certain features similar to uh, each and every object. Okay, they have some defined methods or defined attributes, like every human have their name, their age, and their, let's say, height or weight, etc. Every human has these features. Every object of the human class, I'll say. Okay, every object of the human class have these features. Okay, and every object of the human class can either walk, speak, run, or something else, right? We can all perform these tasks. Okay, there are some things which someone can do extra and someone can do less, but nonetheless we all can perform some basic or simple tasks, right? So just for example, we all belong to the class human. Okay, so basically class is a blueprint to create objects. Class is a blueprint to create objects. So that is why we need classes and objects in the object oriented programming. Now you must be thinking what boring or rubbish things I'm talking about, but believe me, guys, this is going to be a lot more interesting. So let's take an example here. I'll open your favorite shopping website, Flipkart or Amazon. Okay, depends. So this is the home page of Flipkart, right? This is the home page of Flipkart. Now in the functional programming, the thing like if someone wants to create such website, they have to first code this navbar, then these items, then this, then these. Again, the cards for these items, then the scroll feature, then again these cards, right? These buttons, then they have to design all of them, then they have to code it all from the scratch, like the search bar and everything. But just focus on this thing. If I click on, let's say, two-wheeler special vehicles, the data changed. The data changed, but the layout remains same, right? The layout is still same. I still have the search option. I still have my profile option. I still have my cart option, right? So certain features are similar. So what's happening? They are using inheritance in this code. They are using inheritance or reusability in this code. What they are doing, they are basically inheriting the front page, the home page. This is the home page layout, right? They're inheriting this feature, this particular feature to every single page. Like even if I go to other pages, not the become a seller, like any other page. So here we have all the things similar. So they are reusing the code. They don't need to write the search bar again and again for every page. They're not going to write search bar again and again for every page. What they did, they created a class home page. They coded this for one time and then they are using the home class in every single page. Okay, just an example. So they are using the same code. They're using the same code. They're reusing the code. They are not writing it again and again for every page individually. Okay. So that's how object oriented programming helps us in real life. That is how object oriented programming helps us in real life. Now let's get back to our examples and our notes. So first, what is a class? Class is a blueprint to create objects. I hope you guys are clear now. So class is a blueprint to create objects, and objects are like we can take anything in an object. Anything is an object. Okay, everything belongs to a class. So let's say we have a class car and there are three cars available. One is the Polo with the green color. So these are the attributes like Polo green. These are the attributes Mini blue and Beetle red. These are the attributes. And what will be the methods on the class car? Like they can start, move from point A to B. They can make sound. They can horn. Okay, they can honk with them. So these are the methods or some things which a car can perform. So in Python, object-oriented programming is programming paradigm that uses objects and classes in programming. It aims to implement real-world entities. So this is a boring definition. You don't need to, memorize it. You just understood object-oriented programming is made up of two things, classes and objects. Classes and objects, okay? So we have a class which is a blueprint for creating the object. Now there are four key concepts, or I can say four pillars of object-oriented programming. Four pillars of object-oriented programming. What are those? You should remember the names, okay? Now I should say that you should remember the names. First is encapsulation, second is abstraction, third is inheritance, and fourth is polymorphism. I'll teach you each and every single concept line by line, but make sure to subscribe our channel, PyCoding Tech, before that. So let's come to inheritance. I just gave you an example over here of inheritance, right? What is inheritance? Reusability of the code. Reusability of the code. So let's take another example. Uh, Everyone have watched the movie Simba, right? In this we have the Lion King, sorry. The movie name is Lion King, and this guy is known as the Simba. So there is the father lion, okay, and it's the Simba. So what happens in this? He is represented as the base class, and he is the derived class or the child class. So this guy is inheriting all the features. This guy is inheriting all the features from its parent class or the base class. So like four legs, the tail, the ears, the nose, the teeth, the eyes. So these are the things which he is inheriting from the base class. So this is called inheritance. Okay, this is called inheritance. So what is inheritance? Inheritance is a mechanism in which a class acquires the property of another classes, in which one class acquires the property of another class. Like for example, you inherited some features from your parents, right? Like you must be tall or short, depends upon your parents that they are tall or short, they are fair or dark. It depends, right? Totally depends. So this is the thing that inheritance works like in the programming as well. A class acquires the property of another class, and that's what we call as inheritance. And inheritance is basically used for the reusability of the code. Okay, it is used for the reusability of the code. We will understand it by writing real life example, real life code, don't worry. But right now I'm just going through the definitions and the examples. Now here comes the abstraction, the second pillar, which is called as abstraction. So what is abstraction? Basically, hiding the unnecessary details from the user. So when you drive the car, do you have to bother about how the engine is pumping the fuel, how the engine is sparking, how the headlights are getting the power from, how the electricity is being generated, how the wheel is being rotated, how the ball bearing the wheels working, how the absorbers are working? No, right? They are all hidden under the hood of the car, right? They are all hidden under the hood of the car. So that's abstraction. That is what abstraction is. Abstraction is basically hiding the unnecessary details, hiding the unnecessary details from the user which are not related for the user. To drive a car, you don't need to know how the uh, engine is pumping the fuel, right? You don't need to know that. You don't need to know that how the engine is generating the electricity, right? That is used for the creators of the car or mechanical engineers, right? We just need to know the basic functions, how to drive a car, and in case the car is broke down, we should know basic things like how to fix a car, right? And in all other cases, we are going to definitely call a mechanic. So they are the specialists. But right now, for us users, there is no need to show all the functionalities, right? So that is what abstraction is. Hiding unnecessary details. So abstraction is one of the key concepts, and its main goal is to handle complexity by hiding unnecessary details from the users. Unnecessary details from the user. So I hope you guys are clear with the abstraction. Now we'll come to the third, encapsulation. So encapsulation is similar like abstraction. So it's like binding the data together and protecting it from outer variables. Binding the data together and protecting it from the outer variables. So what do I mean by protecting it and binding the data together? You all have heard about capsules, right? You all have heard about capsules. So let's understand the capsule structure, okay? What's an capsule and how does it work? So this is a capsule, right? It has a body, okay, the cap, and inside the body, the medicine is filled, right? Inside the body, the medicine is filled. Why do we fill the medicine inside the body? This body is basically digestible. So we need to protect the medicine, the medicine which is present inside the body. We need to protect that from the outer environment because it get ruined if it gets in contact with the outer environment. So that is the main reason we use the cover to protect it. We use the cover to protect it and hold it together, right? So that is the similar use case in programming of encapsulation. We protect the data and variable methods from the outer interference and also bind them together, okay? So encapsulation is mechanism of wrapping the data and the code acting on the data like methods together as a single unit. In encapsulation, the variables of the class will be hidden from the other classes and can only be accessed through the methods of their current class. Okay, so this is what encapsulation is. Okay, just remember the example of a capsule and you'll get to understand it easily. Then here comes the last but not the least, polymorphism. So what is polymorphism? It's really easy to understand. So let's take your example. Okay, currently you are learning from this video. So you are my student, right? You are my student. But when you go out with your friends, you're their friend as well. When you are at home, you're your parent's child, right? You are their son or daughter, right? So you are present in different forms at the same time. You are present in different forms at the same time. So let's assume with the picture, this guy is a family man, so it's father for the children, it's husband for the wife. This guy is a customer for the shopping. When he went for shopping, this guy becomes a customer. When he goes for an interview, this guy becomes the employer, interviewer, or interviewee. When this guy goes for work, he's definitely an employer, a boss. When this guy is traveling, he's just a traveler. When this guy is doing art, he's just an artist. Okay, so this guy is present in multiple forms, and that's what we call polymorphism is when something is present in multiple forms. Okay, so polymorphism is a object oriented programming concept where one name can have many forms. For example, you have a smartphone for communication. The communication mode you choose could be anything. It can be call, text message, so a picture message. So this is just the boring definition which I copied from the Google. Don't need to worry about that. So I hope you guys are clear with the polymorphism, encapsulation, abstraction, inheritance, and we discussed some of the great examples as well. So if you have any doubts, you can comment below. And in the next video, we are going to talk about the coding part of the object-oriented programming. So see you guys in the next video. Thank you.